Every photo you take, every document you write, every single app you install, it's all being managed by one of the most important, yet kind of invisible parts of your operating system, the file system. It's the real unsung hero, this master digital librarian that keeps perfect track of literally everything you own. Okay, let's dive into how this whole thing actually works.
I mean, think about it. It's an action we do dozens, maybe hundreds of times a day without even a second thought. But behind that simple little click, there's this incredibly sophisticated system just kicking into gear, translating your command into magnetically stored bits on a disk. So what is the file system really saving?
To really understand the system, we have to start with the most basic piece of the puzzle. To you and me, a file is, an icon, a name, a piece of content. But to the operating system, it's something way more abstract and honestly a lot more powerful. So let's break down what a file truly is from the computer's perspective.
Now, the key word on this slide, the really interesting one, is abstracts. Your computer doesn't actually care if your data is on a spinning magnetic disk or a super-fast solid-state drive or even a server in the cloud. The file system creates this clean, logical container, a file, so that your apps don't have to worry about all the messy physical details. It's kind of like a universal translator for data storage.
Yeah, so a file isn't just the data inside it, the words in your document or the pixels in your photo. It's also wrapped up in this package of information about itself, a whole set of metadata that the operating system totally relies on to manage it properly. Think of it like a super detailed shipping label for your data. And this slide shows us exactly where that shipping label information lives. It's all stored in something called a file control block, or FCB. This is basically the file's passport. It tells the OS who's allowed to open it through permissions, when it was last touched, who owns it, and, this is the most critical part, it contains the pointers to the actual data blocks on the disk. Seriously, without the FCB, the file's content is just a meaningless jumble of bits.
So once the OS knows where the data is, it needs to know how to read it. And there are really two main ways. You've got sequential access, which this slide perfectly compares to an old cassette tape. You have to fast forward through everything to get to the song you want. But almost all modern systems use direct access. That's way more like a CD or a Blu-ray. You can jump to any track or any piece of data instantly. And that is absolutely essential for things like databases or video editing.
Okay, so we've got a handle on what a single file is, but what about the millions or even billions of files on a modern computer? Just throwing them all into one giant digital pile would be absolute chaos. And this is where directories come in. They are the filing cabinets of our digital world.
Early systems tried a single-level directory, just one giant folder for everything. You can probably imagine the problem. What happens if two people want a file named report.txt? Total mess. So then came the two-level system, which gave each user their own private directory. That's better, but you still couldn't organize your own stuff. And that finally led us to the tree-structured directory we all know and love. Folders inside of folders, creating this beautiful hierarchy for our digital lives.
And this is so much more than just a technical detail. This hierarchical structure is what brings a real, practical order to the digital chaos on your hard drive. It's the reason you can tuck away your vacation photos in one neat folder, completely separate from the critical system files that your computer needs to even turn on.
All right, let's talk about something we all do. You plug in a USB drive. Now, that drive has its own file system, its own little organized world of files and directories. So how does your computer seamlessly integrate this brand new, separate universe into its own? Well, the answer is a process called mounting.
Mounting is essentially the act of attaching a new branch onto your existing directory tree. The operating system takes the file system from that external device and just grafts it onto a specific point in your main file system. And just like that, everything on the drive becomes instantly accessible. And that right there is the elegant solution. When you plug in a drive and it suddenly appears as, say, the E drive or a new folder on your desktop, that's mounting in action. It makes an entirely separate storage device look and feel like it was part of your computer the whole time, creating one single, unified view of all your files. It's pretty cool.
So far, we've mostly been thinking about a single user on a computer, but file systems get used by lots of people at once, especially on servers. So how does the system stop two people from writing to the same file at the exact same time and completely corrupting it? Well, it needs a clear set of rules.
These rules are called consistency semantics, which I know sounds really complicated. But just think of them as the traffic laws for shared data. They define precisely when a change made by one person becomes visible to everybody else.
This makes sure that when you open a shared document, you're seeing a sensible, consistent version, not a half-finished mess from a coworker's edit.
All right, finally, with all this valuable data and all these different users, there's one last critical job for the file system. It has to act as a security guard, or maybe more like a bouncer at an exclusive club. How does it make sure that only the right people can access the right files? This is all about protection.
Yeah. This quote from the source material just sums it up perfectly. Protection isn't just about security from outside attackers, it's about controlling access within the system itself. It makes sure you can't accidentally delete your coworkers' files and that some buggy program can't rewrite critical operating system files and crash your entire machine.
And the most common way this is handled is through an access control model, just like the one you see here. See, every file has an owner, it belongs to a group of users, and then there's everyone else, which is called the public. And for each of those categories, the system specifies if they can read the file, write to it, which you can see here the group and public can't do, or execute it if it's a program. This simple little matrix is really the backbone of file security.
But how is all this enforced? Okay, this is the really clever part. Your apps can't just touch the disk directly. Think of it like a high-security bank. You can't just waltz into the vault. Any instruction to read or write data is privileged, meaning only the operating system is allowed to do it. Your app has to make a formal request, called a system call. It's like filling out a withdrawal slip. The OS acts as the bank teller, checks your ID against its permission list, and only then does it go into the vault for you. If your name's not on the list, you're denied. Simple as that.
So when you step back and think about it, from a single bit of data all the way up to this complex web of permissions, your operating system is flawlessly managing an entire universe of information. That digital librarian we talked about at the start, it organizes, it protects, and it presents everything with a logic that's been built up over decades. It kind of makes you wonder, if our own brains had a file system this structured for organizing memories, what would we be able to do?